link to the ring as we talked about last week as soon as it uploads to WebEx. So this is Module 8 session, and I'm going to go ahead and pull up my PowerPoint. Hopefully, I was sharing this with Kathleen a little bit. Hopefully, you will find this Module 8 material to be nice break from a whole bunch of algebra and inequalities and solving equations. Now we're getting into ratios, rates and proportions and percents and conversions and a lot of stuff that you use probably on a daily basis if you go shopping once or twice a week or in dealing with whatever you deal with at work. A lot of these concepts you will find that you have used in your daily life. So I'm glad that we kind of get a week reprieve from the intensity of algebra, and we're going to review. And a lot of these things, these concepts this week in Module 8, you will carry over when we get to linear equations and solving using proportions and that kind of thing. So these principles, these concepts will help you in future concepts as well. Let's talk about ratios. What is a ratio? And you probably already are familiar with this quite a bit. Ratio is just a comparison of two values. It can be expressed in two different forms. It can be expressed in fraction form, and it can be expressed in ratio form. For example, we've got 8 oranges and 6 apples, and we want to know the ratio of oranges to apples. Now, it can be expressed in ratio form where we use this little colon to represent the word 2, 8, 6, and then we always want to simplify. We always want to express a ratio in simplest form. So we need to simplify the ratio. Even when it's written in ratio form, 8 to 6 is simplified by writing 4 to 3 because 2 is a factor of both 8 and 6. In fraction form, this should be very familiar. Fractions are very versatile. That's why we make a big deal about fractions, because it can mean division, it can mean a portion of something, and it can mean a ratio of 8 oranges to 6 apples. And we know that to simplify this fraction, we reduce it to 4/3. So a ratio is just a comparison between two values. Let's see how this works. Treat this ratio as a fraction in simplest form. Okay, we've got 21 minutes to 6 minutes. So that's 21 in fraction form with 21 over 6. We always take it as it comes, as it's written. 21, we're comparing 21 with 6. So we put 21 in the numerator and 6 in the denominator. In simplest form, I know that 3 is a factor of both 21, so I can pull a 3 out of 21, and 3 is a factor also of 6. So in simplest form, this is 7 to 2 or 7 over 2. Okay, in fraction form, and this represents the ratio of 21 minutes to 6 minutes. Now, what happens when we need a ratio between two fractions? And again, we can write this in ratio form, 1/4 to 2/3 pounds as a ratio, or we can write it in fraction form. This gives us a complex fraction, a fraction over a fraction. Remember, this fraction means division. Okay, so we can also write this as 1/4 divided by 2/3. Remember, all the way back to Module 1, to divide fractions, we invert and multiply. 1/4 times halves. And multiply, we get 3 over 8. So simplified, 1/4 to 2/3, or 1/4 over 2/3. Simplified is 3 over 8, or 3/8. This is the simplified fraction form of this ratio, 1/4 to 2/3. Let's look at one more ratio, and then we'll get into rates. A pancake recipe uses 2½ cups of flour and 1 1/3 cups of milk. What is the ratio of flour to milk? So we identify the value or the amount, the measurement for flour, which is 2 1/2. To flour to milk is 1 1/3 to 1 1/3. Okay, so this is flour to milk in ratio form. How do we put this in fraction form? Well, we need to change these mixed numbers to be an improper fraction. So 2 1/2 is the same as 5 halves. 2 1 1/3 is the same as, I don't know why that doesn't want to stay, 4 thirds. In fraction form, again, we're going to get a complex fraction, so we may as well just write it as 5 halves by 4 thirds. Okay, I think that's working out. Why did it look right? Okay, never mind. And then this is the same thing as 5 halves times 3 fourths with 15 eighths. This is a simplified ratio in fraction form of flour to milk, 15 to 8 or 15 eighths. Does that make sense to everybody?
Yes.
Oh, okay, very cool. It just didn't match my notes, but I changed one of these values, so that's why I was stumbling a little bit.
So that would be the simplified, and it wouldn't get broke down anymore.
That's because there is no common factor between 15 and 8.
Okay.
Yeah. All right, let's move on to rates. Okay, rates. You guys are probably all familiar with rates. Per person, or miles per gallon, or something like that. Just any kind of rate that you would do between two different things. So the ratio between two related quantities is what a rate is. And an example: 15 chairs for 6 people. You can write that in fraction form: 15 chairs for 6 people, 15 chairs over 6 people. Now we can reduce this rate, this 15 over 6, because 3 is a factor of both. So that simplifies to, okay, so if we have 15 chairs for 6 people, then 5 chairs for every 2 people. Make sense? So still the same thing as ratios. You're going to simplify how you express the rate. Now let's see what this looks like in a problem. What's the unit rate? That means for every 1 mile, how many miles for every 1 gallon? Okay, what is the unit rate in miles per gallon if 675 miles are traveled on 25 gallons of gas? Okay, so we've got in fraction form, we can see that 675 miles were done on 25 gallons of gas, 25 gallons. And so basically, we're going to take this rate of 675 to 25 or over 25 and simplify that. And to simplify, we just divide. So 25 into 675, I believe, goes exactly 27 times. So that's 27 miles per gallon. And you could write it, this is not the simplest version, but in order to express it like we did at the beginning, 27 miles for 1 gallon of gas. Okay, and simplified, we know that 27 over 1 simplifies to just the whole number, 27. Okay, these are pretty straightforward. One more question about rates. What is the unit rate in dollars per hour if $648 is earned in 40 hours? Okay, so we're going to look at $468 made or earned in 40 hours. So how much does that mean per hour that earned? So we're going to have to divide divide 468 by 40, that should give us about $11, not about, probably exactly, and 70 cents per hour. $11.70 per hour if we just divide 168 by 40. Since this is pretty simple, pretty straightforward. We've all done this probably on a weekly basis. Move into proportions. Now, this is a very important concept because proportions can help us solve algebraic equations very simply. All right, a proportion is just a statement of equalities between two ratios. All right, so we've got an example of 5/8 equal to some number over 32. How do we figure out what this number is? There's two different methods to finding or to solving a proportion, a missing value in a proportion. First method that you can use is to multiply by the same number. I should have that by the same number. Multiply by the same value. So if I look at how 8 becomes 32, and again, we did this when we were figuring out equivalent fractions. This is the same thing. Getting common denominators, you're actually creating equivalent fractions and actually using the idea of a proportion because proportions are just equivalent fractions. How does 8 become 32? We multiply by 4. And remember what you do in the numerator, the denominator, you also have to do in the numerator. So I know that if I multiply 8 by 4 to get 32, I have to multiply 5 by 4, and that will give me 20. So that means that that missing number n is 20. Method number 1, multiply the numerator and denominator, figure out whichever has the values, whether it's in the numerator or denominator, figure out what the multiplier is and multiply the other by that and solve for your missing number. Or if that's not possible, and sometimes it's not because sometimes these values don't always work with a whole number multiplier. So when that doesn't work, method number 2 is cross multiplication. When you've got equivalent ratios in proportion form, you can cross multiply and solve for your missing value. That's 8 times n, 8 times n or n is equal to 5 times 32, which is 160. So then when you solve for n, you get n is equal to 20. So either method can be used to solve for a proportion, either multiplying by the same number, both in the numerator and denominator, or cross-multiplying. Okay. And sometimes you can use method number 1, but sometimes you're going to need to use method number 2. Now let's look at examples. The missing number in the proportion. Now, here we have n in the denominator of the first ratio. So I need to look in the numerator and figure out what happened here. So I'm going to have to work backwards since I have to work backwards here to find n. So what happens here? How do I make 5 become 1? Well, I would have to divide 5 by 5. Reduce 1. So if I divide by 5 in the numerator in my second ratio, I'm going to have to do that same thing in the denominator, divide it by 5. So that tells me that n has to equal 11 because 55 divided by 5 is 11. So really that proportion can be written 1 over 11 is the same as 5 over 55. Using method number 1. You could also cross multiply and say 5 times n, same thing as 55 times 1 or 55. And then just divide both sides by 5 and you also get n is equal to 11. So both methods will produce that same value for n. Now how do we, let's look at the second example, 6 over 17 same thing as some number over 51. So let's try method number 1. How does 17 become 51? How does 17 become 51? Well, you can multiply 17 by 3, and so what you do in the numerator, you have to do, in the denominator, you also have to do in the numerator. So 6 times 3 will give me the value for n, so n must equal 18. Again, you could also cross-multiply. So cross-multiply and do 6 times 51, which gives you 306. I'm a little slow tonight, is equal to 17 times n. And if you divide 306 by 17, you'll get that n is equal to 18. This method should give you for the missing in your proportion. Now let's look at a word problem and see how this helps us when solving word problems. All right, David read 40 pages of a book in 50 minutes. So how many pages should he be able to read in 80 minutes? All right, set up a proportion to solve this. Okay, we know the rate of 40 pages in 50 minutes. So let's write that as a ratio, 40 in 50 minutes. 50 minutes.
Sorry.
Okay, so how many pages should he be able to read in 80 minutes? Now, if you have pages over minutes on the left, then you have to have pages over minutes on the right. So you have to be comparing the same ratios in the same manner. Pages to minutes is equal to pages to minutes. So how many pages? Well, we don't know that, so we're just going to call that in pages in 80 minutes. Here's one of those things that would be difficult to use method number 1 because I'm not sure that there's a whole number. In fact, I'm positive there's not a whole number that I can multiply 50 by to produce 80. I'm going to use method 2 and cross-multiply to find out what n is equal to. So I'm going to use my cross-multiplication method to solve this proportion. So that's 50 times n is equal to 40 times 80, or 3,200. To solve for n, divide both sides by 50. I'm going to get that n is equal to 64. So David should be able to read 64 pages in 80 minutes. So this is your final answer. Any questions so far before we move on to percents? We're in proportions. This is very important because you're going to be using proportions. You can either use method 1 if it works out for you, multiply by the same number in the numerator and denominator, or use your cross-multiplication method to solve a proportion. Now let's move on to percent notation and conversions. Most of you are probably very, very, very familiar with this because it has to. We use it a lot in our real lives. So let's talk about how to convert a percentage to a decimal. Well, we know that percent is just that number over or divided by 100. So when you divide any number by 100, it's the same thing as moving the decimal point, which in a whole number is all the way at the right of the number. When you divide any number by 100, that means you're going to move this decimal point 2 places to the left, making that number a smaller number. Okay, you're going to move that decimal point 2 places, and this becomes 145% is the same thing as 1.45. This is your final answer. So when changing a percent to a decimal, take your percent and move the decimal point 2 places to the left from the end of your percentage value. Right, let's look at how to write a fraction as a percent. Now the first one's relatively easy because we've got 73 over 100. This is already out of 100. Percent, cent means 100. So it's 73 out of 100. We know that that is just 73%. Now I write 5/8 as a percent. Well, we could go about it two different ways. Since we just talked about proportions, we can create a proportion. Say 5/8 is the same as some number over 100. And then we can cross multiply equal to 500 and divide 500 by 8. Get that n is equal to 62.5. So that would be 5/8 is the same as 62.5%. Or we could just take 5/8 and divide 5 by 8 and change 5/8 into a decimal. Okay, 5/8 is the same thing as 0.625. And change a decimal into percent. Remember, percent to decimal moved it 2 places to the left, moved the decimal point. To change a decimal to a percent, we move the decimal point 2 places to the right, giving us a bigger number. And so 0.25 becomes 62.5%. So either method you want to use, if you just want a straightforward divide, change your fraction to a decimal, change your decimal to a percent, or set up a proportion, 5/8 is the same as some number over 100, and use your cross multiplication method to solve to give you that percent. Any questions about that? Let's move on then and continue on with conversions. We're going to convert percent now to a fraction. This relatively straightforward because we're just going to, we know a percent is that number over 100. And we simplify the fraction. We simplify that fraction. So I know that 4 is a factor of both 32 and 100. So 32 over 100 becomes 8 over 25. 32% is the same as 8/25. Our second example is 120% is what fraction? So I know that percent means that number over 100. The thing I'm going to do is divide both terms by 10 to get rid of those zeros. So 12 over 10. And now I continue to see that 2 is a factor of both 12 and 10, and I'm going to simplify further. So 120% is the same as 6 over 5, or 6/5. It's more than whole. That's pretty straightforward, pretty simple. Let's look at how we apply this to real-world situations. 30% of 1,200 high school students have taken the SAT test. How many students have taken the test? Now, if you read this correctly, the word of usually indicates multiplication. So we're going to multiply. How do we multiply a number times a percent? The simplest way to do that is to change the percent into a decimal. Okay, 30% is the same as 0.3 or 0.30, and we're going to multiply that to 1,200. Becomes, if we multiply 1,200 times 0.3, we get 360. So 360 students have taken the SAT test. This is a good place to use just your 4-function calculator. You know, even on quizzes and tests, you're allowed to use your just a calculator, basic calculator with adding, subtracting, multiplying, and dividing. That makes these problems super simple and very, very straightforward and easy to work with. All right, so talk about changing a decimal into, a percent into decimal. We're going to do the very opposite we did in changing a decimal into a percent. So the to write this as a decimal, to move this percent into a decimal, we're going to move it 2 places to the left. 2 places to the left, 1, 2. Move that decimal point there and fill in wherever you don't have a place value with a 0. So 3.7% is the same as 0. And I don't know why this pen, I keep saying I'm going to fix it, but I don't know how. 0.037 decimal form. 156% is the same as 156, moving the decimal point from the end 2 places, so that becomes 1.56 in decimal form. All right, what about a very, very minute percent, or 0.22%? Well, we need to move that decimal point 2 places again to the left. So that's 1, 2. We've got to add one more 0, so that becomes 0.0022, a very tiny, itsy-bitsy number. You probably already know this. Is that true? Review for most of y'all? Have I lost you?
No, I'm here. Yeah, somewhat
okay.
of review.
Okay. Good. Good. Interrupt me if you have questions or if I do something wrong. Okay. Now, take a decimal, write it as a percent. I think we've done this before. We're going to do it in reverse. Okay. So in decimal form, we have to move the decimal point 2 places to the right and make it a percent. So 0.84 is the same as 84%. And 5.25 as a percent is the same thing as 525%. And we move 2 places to the right for this decimal, so 0.014 becomes 1.4%. Very cool. Okay, it's just backwards from what we did here. Decimal, from a percent to a decimal is 2 places to the left, and from a decimal to a percent, we move the decimal point 2 places to the right. All right, we're almost there. Yay! How does this apply? And we've probably all run across this, gone to a store and seen the price of something and remembered that there's sales tax. So what is the sales tax? It's not asking for the total that you're going to pay. It just wants to know how much tax am I going to pay on a $300 coat. Its tax rate is 6%. So anytime you do that, you want to change your percent into a decimal. So we're going to take $300, multiply him times 6% in decimal form is 0.06. $18. $8. And that's what we're going to pay in tax. So we'd pay $300 plus 18 or $318 total. All right, working with percents. Okay. Again, this proportion idea is going to help us tremendously when working with percents. Because we're going to set up a proportion. We'll look at something like, what is 75% of 4? Now, these are more straightforward, and we will use this probably when we don't know one or the other of these. This is more straightforward, but just remember this little proportion formula, okay? Part to whole is equal to the percent value to 100 or over 100. All right, so or you could say, well, I won't even get into that because that might be confused. Part to whole is equal to percent over 100. So what is 75% of 4? Well, this is more straightforward. I know that of means multiply, so I'm going to multiply 75% or 0.75 times 4, which is going to give me 3. Okay, that's pretty much straightforward. Let's look at others. Very similar. Okay, we're just going to use the multiplication thing. What is 25% of or times 420? So that's just saying the percent into a decimal and multiplying that times 420 and that would give me 105. Let's just, that's right. All right, the second example, we're going to multiply 15% of 12. You just multiply. Change the percent to a decimal. Multiply that times 12. That's going to give me 1.8, I believe. That's straightforward, right? Let's look at it in this way. Whenever we don't know the number that we're multiplying 50% times, okay? So 50% of what number is going to give me 64. This is when I need to use my part over whole to percent over 100. That's to use my formula. So this the part, because the number that we're multiplying 50% to is the whole. Okay, so we need to know the whole number. So 64 over what number? 50 over 100. It's the same as 50 over 100. So this is where a proportion will help us. So we're going to cross multiply 50 times number is equal to 6,400. And I believe that becomes, if we divide both sides by 50, I think that number is going to be 128, if I worked it out correctly. Let's look at the second one. 84 is what percent of 84? Okay, 84 is what percent of 24? Well, the of part is the whole part. So 84 is what percent of 24? So 84 over the whole of 24 is what percent? We don't know the percent, so we put in over the 100. Okay, so this is the whole because the of part is your whole number, your whole value, which becomes your denominator. And the is part is in your numerator. That's the given value after you multiply it to this percent. So set up the proportion this way. 84 to 24 is the same as what percent over 100. So this is where we use cross multiplication again. 24n is equal to 8,400. So solve for n, we divide both sides by 24. So n becomes 350. So I know that 84 is 350% of 4. That makes sense. Since 84 is larger, it would be multiplied by a higher percentage than just 100%. The part is larger than the whole. Does y'all?
Yeah.
Okay. All right. Just checking. So the last example, 27% of 47 is what number? So we don't know the numerator or the part, but we know the whole. I'm just going to use this proportion because we could just simply straightforward multiply 47 times the decimal percent, but let's just go with this whole proportion line of thinking. We don't know the part, but the whole is 47, and it's multiplied times 27% or 27 over 100. So you could do it either you could write it as a proportion and cross multiply, so that would be 100 is equal to, I believe, 269. Divide 1269 by 100, and you find out that n is equal to 12.69. Or I just know that 27% or 0.27 times 47 in the calculator is going to give me 12.69. You want to do it. You want to set it up as a proportion because this is the more straightforward method. These probably require more of your proportion to understand what you're solving for. Let's move ahead to what this looks like in working with percents further. All right, you've got something that has an original purchase price of $96, and the tax rate is 6%. So how much sales tax are you going to pay on a $96 item purchase, and what's the total price that you're going to pay? So first of all, you're going to multiply 96 times 6% or times 0.06. And you're going to get a sales tax of $5.06 when you do that. Find the total price. Obviously, you simply add the tax and the purchase price, and you're going to get $101.06. A neat trick. If you didn't need to know exactly what the sales tax was, if they said, okay, you purchased something at $96 at a 6% tax rate, what is the total price that you're going to pay? Instead of multiplying by 0.06 to give you just the sales tax, you can multiply 96 by 1.06. That 100% of your original price, or 1, and then you're adding this 6% sales tax. This is an all-in-one step. If you don't need to know your exact sales tax, if you only need to know your total price, you can multiply the original purchase price times 1 point whatever your sales tax is, and that automatically gives you your total price. That's just a little shortcut if you don't need to know the exact sales tax amount. How does this look when you're buying a house? And that's very important because this is a very important percentage because houses are quite pricey. So how do you figure out the commission on a sale of a $124,000 home? We're going to multiply $124,000 to decimal version of 5% or 0.05. Put that in the calculator, and you get $6,200. You're always going to want to change your percent into a decimal and multiply it to your purchase price. That will give you the commission or the tax, whichever answer you need. Let's continue moving on. We're almost done here, and then I'll take some questions. Now we're looking at a sale, a discount. $879 television is on sale for a 15% discount. First of all, we need to find the amount off or the discount price. Again, we're going to multiply 879 times 15% in decimal form, or 0.15. It's going to give me a discount of $131.05, if I did that correctly in my calculator. I didn't do that in my head. So then we're just going to subtract, since this is a discount, we're going to subtract 879 minus the discounted price of $131.85, and that's going to give us a sale price before tax of $747.09. Or, if you need to know this, just like I showed you the shortcut of the other, if you didn't need to know exactly how many dollars off, you didn't need to know, if you wanted to go straight from discounting to your final price, you're going to subtract this percent from 100%. Okay, and that would give you 85%. So what you're going to pay is 85% of your original price, or 0.85, and will give you your discounted price. Okay, don't need to know exactly how much the discount is. You just wanted to discount and identify your final sale price. You could subtract your discount from 100%, change it to decimal, and multiply by your original price. A little bitty shortcut there. Okay, let's look at this. Now, this is a little bit different because we're working with amounts, an original amount and a new amount. They want to know the amount of decrease. So that's just a straightforward subtraction problem. 225 minus 180. How much of a decrease is that? Well, it's 45. Okay, it has gone down by 45. And what is the percent of decrease? Okay, whenever you are looking at the percent of decrease, we always need to compare it with the original amount. Okay, we need to compare it. So we write a ratio, the amount of decrease, which is 45, and compare it to the original amount. Always compare it to the original amount. And that's going to give you 0.2 or 20%. Remember this, when you're looking at discounts or markups or increase or decrease, okay, increase or decrease, you're going to do the new amount, and you're going to subtract the original, okay, the amount minus the original, and then you're going to compare it to the original. Here, we would say, let me put this in a different color, 180 amount minus the original amount, and divide that by the original amount. Percent of increase or decrease. Okay, so because the numerator gives you a negative number, negative 45, I know that's a decrease. All right, so a decrease compared to the original, and that becomes 0.2 or a 20% decrease. So just remember this formula. If you want to know the increase, the increase or decrease, your new amount minus your original amount divided by your original amount. Let's look at the last problem here. Here's another percent of increase, and I'm going to use that same formula of the original and the new. All right, subtract these. So a savings account increased from $400 to $420. What was the percent of increase? So I'm going to take the new amount, $420, subtract the old amount, $400. That's not 7. That's a 4. It looks like 7, though. 420, 400 over the original amount of 400. That's going to give me 20. 400, which gives me a decimal of 0.05, which is the same thing as 5%. And because this was positive and it increased, this is going to be a 5% increase. All right, so these are all the concepts for Module 8. Are there any questions on these particular concepts? To review. You guys are very simple tonight. So no questions then?
Thank